All right, question number 3. All right, the question starts, the following diagram shows 3 quadrilaterals, P, Q, and R on a square grid. Q and R are the images. So Q and R are the images of P after it underwent 2 different transformations. All right, so let's get to the question. So P is the object and Q and R are images. All right, R and Q are images and P is the object. The object is the shape before it is moved. So let me just say it again. The object in a transformation, the object is the shape before movement takes place, and the image is what you get after movement has taken place. So let's see the question. The question A says, on the grid on page 9, draw the image of quadrilateral P after a translation, after AI translation by the vector 10 minus 4. So 10 minus 4 is a translation vector. Now, for a translation vector, the top value tells you how to move the shape horizontally, and the bottom value tells you how to move the shape vertically. Now, the fact that the top value is positive, it means I'm going to move the shape to the right. And the bottom value being negative means that after I move the shape to the right, I'm going to then move the shape 10 units vertically downwards. So let's do that. So let's move P 10 units to the right. If we do that, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So horizontally, it's going to end up on that line. All right. Then we're going to move it 4 units downwards. 1, 2, 3, 4. So this would be the new position of the top vertex. That would be the new position of the top vertex. All right, so 10 units to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4 units down, 1, 2, 3, 4. This is the new position of the top vertex. And how do we move shapes? How do we move shapes in a transformation? We move it 1 vertex at a time. Now, after I move 1 vertex, you just move all the others. And once you move all the others, then you just redraw the shape. All right. So all I do is I move all the vertices and then I just redraw the shape. All right. So that's P. Let me see, what did they say we should call this? We should call this P prime. All right. We should call the image P prime. So P prime is the image of P after a translation of 10 units right and 4 units vertically downwards. Next, we're asked to reflect P. Remember, no, your image is what? Your image is P. Your starting point is always P. We're asked to reflect P in the line y is equal to 0 and label the image P prime. Now, first we need to identify the line y is equal to 0. Now, your y lines are horizontal lines. Now, the x-axis is the line y is equal to 0. So the x-axis is my mirror line. So we're going to reflect P in the x-axis. So guys, in a reflection, the object and the image are the same distance from the mirror line on either side of the mirror line. So P is 1, 2, 3, 4 units from the mirror line. The image P double prime is also 4 units on the mirror line, but on the other side. So if you do that, So the image is going to be 4 units on the other side. 1, 2, 3, 4 units. That is going to be the new position of that bottom vertex. That is going to be the new position of that bottom vertex. All right, so it's 1, 2, 3, 4. The new position is going to be here. So once you reflect all of the 4 vertices, you just simply join them together. Once you reflect all of the 4 vertices, you simply join them together. All right, so it's very easy for me using the software. All right, so P is the image, sorry, the object, and this image I'm calling P prime because that is the instruction I received from the examiner. All right, so I got 3 marks. Let's see if we can get the rest. The next is where to describe fully a single transformation that maps quadrilateral P onto quadrilateral Q. So let's map P onto Q. So once you have any understanding of transformation, you'd understand that for P to become Q, the only transformation that's going to make PQ is an enlargement. All right, if you're going to describe an enlargement, you need to know 2 things. You need to know the center of enlargement and you need to know the scale factor. So let's identify the center of enlargement. Now, in an enlargement, a line connecting corresponding points on the object and image always pass through the center of enlargement. So to identify the center, I'm going to draw a straight line through corresponding points on the object and on the image. So I did that. Corresponding means that there are points in the same position. All I have to do is draw a straight line through corresponding points on the object and the image. These 2 points are corresponding points. They are the same points on the object and on the image. I'm going to draw a straight line through those 2 points. Anywhere the 2 straight lines intersect, that point is my center of enlargement. So I draw my straight line. So you're going to do this using a ruler. You're going to do this using a ruler. All right, so use take your geometry set to the exam, use your ruler, and draw 2 straight lines like that. Anywhere the 2 straight lines meet, this point here is the center of enlargement. So the center of enlargement is -10, 7. The next thing I need is I need the scale factor. Now, the scale factor K is equal to distance from center to image divide by distance, BIST, from center to object. So that is K, all right? I could write it on the next page, but I just want to work out the distance first. Now, from the center to this point here, it's 1, 2, 3 units. From the center, now that point is a point on P, which is the what? Which is the object. So that is the distance from the center to the object, that is 3. So K is equal to, that bottom value is 3, the distance from the center to the object. Let me undo all of that. All right, so K is equal to, the bottom value is 3, the distance from the center to the object. Then let's get the distance from the center to the corresponding point on the image. This point to this corresponding point on the image, the distance is 1, 2, 3, 4, 5, 6, 7, 8, 9. The distance is 9 units. from the center to the corresponding point on the object on the image. All right, so K is 9 divided by 3. K is equal to +3. So if you're going to describe an enlargement, you need two things. You need the center of enlargement and you need the scale factor K. So then I would then say now P is map to Q. That's what that arrow means, is map to Q by an enlargement center. The center of the enlargement is -10, 7, and scale factor K is equal to +3. Remember, K is equal to distance from center to image divide by distance from center to object. So it's a distance from the center to the image divided by the distance from the center to the object. All right. The next thing they want to know what transformation is going to map P to R. Which transformation is going to map P to R? Now, the transformation that maps P to R is a rotation. The transformation that maps P to R is a rotation. Now, for rotation, you need the angle of rotation, you need the direction of rotation, and you need the center of rotation. It's three things you need. Now, there's a construction approach for finding the center of rotation. And I could show that to you at some later point. It would involve something like connecting corresponding points on the object and the image. So you'd connect corresponding points on the object and the image, and then you would do some construction procedure, something like that. You would bisect, and then you do something like that. All right. All right, these lines don't go very easy. All right, so you can ask your teacher to show you that, because I don't have the capabilities to do it here. But essentially, when you do the construction, the center of enlargement, let me see if I can spot it. Yeah, man, the center of enlargement is here. Sorry, the center of rotation is here. The center of rotation is minus. Now, here's how I would know from just looking at it. Moving from the center to the object, which is P, I go up what? 2 units and go across 3 units. So it's like I'm rotating that L and I'm rotating that L in that direction. So if I rotate the L, the 2 vertical is going to become 2 horizontal, and the 3 horizontal is going to become 3 vertical. So this is 2, 3, and when I rotate that 2, 3, it's going to become 2, 3. It's like you're rotating an L that's connecting the L from the center to the object. You rotate that L 90 degrees to the left. That direction is anti-clockwise. So to describe the rotation, also I know it is a 90-degree rotation. See, in a 90-degree rotation, vertical lines become horizontal. In a 90-degree rotation, vertical lines become horizontal. So you realize that vertical line in the middle became a horizontal line. So I know that is a telltale sign that it's a 90-degree rotation. So then I would say P is mapped to R by a rotation, sorry, it would be by an anticlockwise, by an anticlockwise rotation of 90 degrees about center, what is it, -4, 2. The center of rotation is -4, 2. So whenever you're describing a rotation, the description for rotation must have 3 elements. You must have the direction of rotation, that is anticlockwise, the angle of rotation, 90 degrees, and the center of rotation, which is -4, 2.